test. Let me refresh Twitch. It says live. I should be live. Okay. Hello, everyone. Welcome back to the project. On Tuesday, we've made quite a lot of progress. We've finished dealing with most of the expressions that appear in the definition of a constant. We've made some progress on the way we declare the current scope. We've made some investigations about how enums are put into scope in Rust. We've made some overall general progress on Tuesday. And I guess today there's two things we can make progress on. Either we figure out something about how vectors and strings are going to work so we can fully finish dealing with constants, or we decide that we can push this back to later and we start dealing with functions. And I am kind of in the mind of doing functions now. Especially because it's going to reveal a lot of things that are wrong in the way we compile our modules at the moment, and there's going to be a lot to do. So we'll see how much progress we make, and let's get started. Oh, and also, I've uploaded all of the video of May on YouTube. It's just gonna take it just takes a while to upload all of them. I just need to go through the process of adding labels and title and everything. They'll be out before this weekend. Okay, let's get started. I think we were here. Analyze function, which is, gonna be the biggest part of all of this, but hasn't been done yet. So I guess this is where we start. To have a start, let's have a look at the AST again. And I want to look at a function info. What is that? There we go. Just to have in mind what we're dealing with here when we're trying to analyze a function info is this. We have the identifier, we have the type parameters, because it might be a generic function. And then we have the arguments to it, the return type, if any, and the list of statements that appear in the function. Right off the bat, I'm going to mention something. I am going to, I think, use a C++-like approach to generic functions, as in a given module will list what functions it requires, and will store within its result, because I'm going to support incremental compilation at some point. It will store all of the instantiated versions of a function that it requires. For instance, if this module exports the module I'm compiling right now exports a function foo, which is generic over some type parameter t, it will not the compiled version of this module will contain the declaration, the solved declaration for this function, but will not contain the instanced version of this function. However, if another module, let's say bar, imports this one and use foo of int, it will contain the instantiated version of foo of int and all of the function it uses. That way, when we're done compiling our main, we will be having the full list of instantiated functions. That's the plan. There's a few unknowns yet. For instance, how do I do type checking when I don't have the type yet? I still think it's valuable to do some amount of type checking on generic functions, even though I might not have the type of them fully at this point. But it means there's going to be a bunch of places where I'm going to have to just suspend type checking and resume when I know what the concrete type is. Because since we don't have trait in this language, I cannot just check like, oh, we're using addition on this type t that is in that is the parameter to this function. Therefore, t must support the trait add or something like this. We don't have traits. So I'm going to use the C++ approach where type checking is done, that kind of checking is done when the type is instantiated, even though we could probably deduce what types are valid or not during this phase. I think it's the simplest approach. And it works for C++, so, So this is gonna be the approach to this. And what we're gonna need, the only thing is gonna change is basically at this stage, for this analysis phase, what is going to change is like the type checking will sometimes fail, as in everything that involves a type parameter will succeed. Like, A, we're giving a value to that function, it expects an int. Here on the side, we have t, a type parameter, success, because we don't know what t is yet. So therefore, everything regarding type checking will be successful as long as it's type parameters. And the only thing is, at the end of this, when we have this notion of like instantiated functions that are bundled within a module, especially since I think for incremental compilation, I think I will just include the images of the functions when they are instantiated. I'll have to register that this function is, like, I need to have a mechanism to register functions that are instantiated as part of this process. But otherwise, this code is going to be the same regardless of whether a function is generic or not. That's the plan, at least. So, let's get started. This is not a big, difficult thing. We're just resolving the type, making sure that the type that appears in the return type of a function is indeed a type, if it is a type at all, if there is something at all. I guess otherwise, I think my documentation, I'm using the same thing as Rust more or less, and I think I have it written in the documentation. Do I have the type? There we go. Okay, so basically this unit type is, I'm going to be using this unit type even though I don't have tuples at this point of the language to mean the same thing as Rust and kind of Haskell do, which is like this is no value basically. And I'm going to be using this void thing to indicate something that always succeeds at type checking, but is not a valid type, to indicate like panic and stuff, because panic has a type that is compatible with any expression. Okay. That means I'm going to need a few things. In the built-ins, I'm probably going to need... No, it's in built-ins. I am going to need a few more types. Hello. So yeah, today we're starting the function analysis, and there's a lot to do. So what I'm going to do at the moment is I'm going to add in the built-in types that the compiler is aware of despite not being user-defined. I'm going to be adding two of them. I'm adding the empty tuple, which when we have tuple support will be removed from this list and just be the actual tuple, but we don't have tuple support yet. And I will as well introduce this void one, which is the type used for built-in functions like panic, which don't exist yet, but will at some point, that basically always type checks regardless of the thing, so that we can do panic without having to worry about type checking. That kind of stuff. And we are gonna need to add a few more things. Okay, unit type, and I'm gonna call it void type. That way I can refer to those built-in types in the code. Okay, so now I can do something slightly different. Rather than a traverse, I can do a maybe pure unit type, resolve type of the fun type. So if there is a type that appears in the function as the return type of the function, we resolve, we check it's a type, we do all the necessary type checking based on the parameters. Otherwise, we decide that the type of the function is unit type. actually, at this point, do we do that? The downside of doing this at this stage is the output of this phase is still based on the AST, which means I still have a maybe. Yeah, maybe I don't need to do that at this point. However, this function is already wrong because this resolve type will look into the current scope to check for types that are in scope. And it is missing some types that are in scope, specifically type arguments. We've already done something like this for something else. I don't think we did it for constants, but I think we did it for type resolving. Where did we do that? Here we do the substitute types. I'm fairly certain at some point we did that. Resolve path, no. Huh. I'm surprised. I thought we had done something like this for type, because I think we've done that somewhere. Because if I look at this file here, which is our test file so far, if I do struct foo of t is a struct that contains, can I remove all of that from last time? If I have a struct foo of t that contains a field x of type t, we have type a which of t, which is foo of t or something like this. And we have type b equals a of int. Unless I'm mistaken, this used to, oh, I've made some changes, so I need to make sure. Actually, I can just run the binary directly. Wait, is it in this? Yeah, probably. I expected it to be in stack work for some reason. Nope. Where is the binary? There we go. There it is. I just don't want to recompile. There's a syntax error in this file. Because this is not the proper syntax, is it? Is it? Yeah, it is like this. I'm missing a semicolon somewhere here. There we go. Because I'm expecting, so if I look at foo takes a parameter t, a value x, type t, a is indeed for a t, it is a foo of t, and b should resolve to a foo of int. And that's what it does. So we do have substitution for type aliases. So it works. That's good. But that means somewhere in this piece of code, there is something that does the substitution. Where was it again? It has to be when I do type aliases. Those functions are when you initialize the context. So that's not where this is going to be. Is it just in resolve type? Possibly. So that would be here then. I'm surprised that is not at all in the I could check something much easier to check. I have here in name, I have a type parameter that indicates that something is a type parameter. Where do I put type parameter in this? Here, substitute types. But that's not... Ah, there we go. Gotcha. That's where I do this. When I resolve a type alias, when I see the declaration, rather than doing it later on when I try to resolve a type, I do it once. Here I am looking at type alias and there is a parameter type. And for each of them, I put them in the local known types. And I do the same thing in all of those things. And I guess I can do the exact same with the exact same warning when I take care of a function. Because I do block. Okay. So now this is going to work just fine because now the local type is going to be resolved knowing that there is a type parameter t. So if the return type of the function is t for a parameter t, it will now work, which it wouldn't have otherwise. Now, what else do we need to do at this point? I guess we have to also add names of arguments to... Oh, in none of those have I checked that the type aliases are okay. I have not validated them in any way, shape, or form. So for now, if I try to do a type alias that parameters by two types t and t, I'm going to allow it. So let's fix that for all three of them. And let's make a helper function for this, which is going to be I guess I could make it with like this with type parameters using the with approach. And it's going to be a function that, given a list of identifier and given some value in my monad where we do everything, will return a value in our monad where we do everything. And this is basically the thing to call with the altered context of those things being in scope. So let me copy what we will have done in a few places, like this. So with type parameters, here's gonna be the parameters themselves. It's not exactly a callback because it's not taking as arguments any of the things, but I guess it's close enough. I'm gonna call it callback or action. Action, there we go. And what do we do here? We do basically this. For each identifier in a list of parameters, we put that in the scope as being just something that refers to that type parameter. We add that to the local context. I use local because I want to manually push some state and then have to pop some state in case of error. With local, it is done automatically by this function that behaves kind of like this with pattern, and I can give it the action. And now, not only is this better, but I can fix it. I can fix because I want to check Um, there again, I think I will want to have a thing where I collect errors in a way that doesn't necessarily short circuit, but that's gonna be something we can do later. I think for now, what I'm gonna do is for everything in group of sort of the parameters, I'm gonna do a case. Empty is impossible. One element is just fine. That means there's only one parameter with that type. All good. I guess actually I could generate the list at this stage. Yeah, I guess I could do that. Which is going to be therefore an fmap m from list, which I guess is not a let anymore because this is in the current monad. It's impossible here because well, thank you. I'm sorry I missed your message. I hope it wasn't too long ago, but yeah, thank you for tuning in. This is impossible because what group does is basically transform a list of value into a list of values by combining like nearby values that are identical. So if I have a list AAB, it will create a list of the list AA and the list of the list B. And as a result, an empty list is impossible because it means not that the overall list is empty, but that the list contains an empty list. That makes no sense. That's impossible. They could have used a non-empty list as the output of group. They didn't. I could make that as a prelude function, I guess. And as a result, if we encounter this, that's just impossible. I'm fine using error for those cases. If we find one element, that's perfect. That's our case here. I can return this. And therefore, I might just name it. There we go. And in the case of any other case, we're going to want to let's see my diagnostics. Do I have no, I don't have I will probably want to have the name of the type in which this happens, and the identifier will be the one of the parameter that is wrong, which means I am going to need the name here for error reporting purposes. Duplicate type parameter. Type name, and I guess I can match this since it's guaranteed to not be empty. I can match this as being identifier followed by anything, I guess. I'm just gonna align them so it's a bit more clear. There we go. Okay. And now the output of this, I still have the type names that I had before, but now I've detected that if there's a problem, I've detected it. Because at the moment, if I try, type C of T and T and T is T, I think this compiles just fine at the moment. Yep. And C is just a value of type T. So this is broken. And now with this, it won't be anymore. I still think it might be a good idea to have a warning if it shadows an existing type. How would I go about this? I'm just gonna introduce report warning, I think, which is exactly the same thing, except it doesn't short circuit. Okay. So we have our first warning, which is going to be still be here in, where did I put that function? Here. Okay. I don't know if it belongs here. We might move it later. So here I am going to want to do a check, which is can I move those two lines? I guess I can match like this, which means it matches at least two elements. And because that way here, I can open a do block and it's a bit more visually satisfying. Okay. Just gonna check something very quick. How many people do I know that are playing Deltarune right now? Only one. Surprising. I was expecting that number to be higher, but I don't think it has been zero at any point during the last 24 hours. Okay, so here what I want to do is I want to check if in the current scope there is a type named T. Well, T. They name the same thing as the type parameter I'm having here. The question is, do I want to check that there's anything with that name in scope, or do I want to check it only shadows types? I guess I want to only shadow types. A big downside of this with errors and everything is I have no way to check that a type exists or not. Like I would need the same version of this, but a resolve type maybe, basically, that only tells me, yes, this type is in scope. No, it is not. But I guess that's different enough that I can do something like this. Probably worth doing this anyway. Okay, the thing is, I don't care necessarily about doing type substitution or anything. I just want to know. Hello, how are you? But yeah, here the only thing I want to know is where the type comes from. I don't think I care about anything else. So I think the only thing I care about is if that path is a type, that's what I want to return, basically. So even if it's just a type name, I don't like a type alias. I don't care about any of this. I don't need to do type substitution or anything. That's just path. Wait, I was too aggressive. There we go. If it's a constant, I don't care. If it's a function, I don't care. In those cases, it's a pure nothing. Oh, but there's a problem there. I'm using resolve path, which will error with an error if that's ambiguous, which is not what I want. Which means I think I can't reuse existing components for this function. I'm going to have to rewrite it myself. Okay, that's fine. And this is gonna give me, instead of a maybe of a path info, it's gonna give me a list, which is all the ones that are being shadowed by the type declaration. Because even if we shadow more than one, and therefore using one of them unspecified would be an error, for shadowing purposes, that's fine. So I've started this evening with doing analysis of functions, which is last time we're done with almost done, except for like strings and vectors, which are things we haven't dealt with yet. We're done with analyzing expressions in constants, which means constants that refer to other constants, or that do casts, or do struct expressions, or like field expressions within structs. All of this, they're all resolved fully at compile time, enums and everything. So that all works. So it's time to do the last part of this analysis phase, which is functions. But in doing so, I started doing something like this, which is like, oh, I have to add the type names of the type parameters in the scope so that if my function returns a value of type t, where t is a type parameter, t is within the scope, and this type checker knows what t is. But in doing so, I copied code from the other top level analysis functions that does the exact same thing, and I realized that it had a bug. Specifically, I discovered that I don't check for unicity of type parameters. So this type alias declaration is valid. It's wrong, but as far as I check at the moment, my compiler is happy. So what I've started doing is doing a function that like takes care of doing first adding the type parameters into scope, and two, report an error if there are duplicates, and three, I'm adding a warning, our first warning, when because I've had this to do for a while. You've declared that the type parameter for this function is named user. That shadows an existing user type, which in turn means I have to rewrite some of my type resolution function, because in this case, if I try to resolve a type and it doesn't exist, that's not an error. Hence, writing this resolve type maybe function that is trying to, that's gonna give me a list of types that match a name, and that list, yeah, basically. You can see it here. In here, we're like a of t is a foo of t, and foo takes this t argument and makes and has like an x here of type t. And b is a of int, so it translates to a foo of int. So it's a foo that contains a foo that contains an int, which means that if I were to make a function that returns a b to have a foo, or I guess I can make a constant because those type check already. If I wanted to make a constant foo of type b, it would need to be a foo. Oh, would this need a type argument, or would it be fine without? Have I messed up here? Ah, well, we'll check. This would be a foo that contains a field x, which is a foo that contains a field x, which is an int. I am not sure this is going to work without the type arguments. Let's see what my compiler says. Incorrect type parameter count. Here I am saying foo, but I'm not specifying the type of foo. So this is a foo of int, which is not a very convenient type to write. And this is a foo of int. Error wrong type. I have a place where my type checker does equal comparison on types, which is wrong because, aha. Okay, let's try something else. What if I have a foo of int? This would be something like this. Are you happy with this? You're not happy with this? Because when I go look at the struct expression, I'm expecting a value of type t because I did not realize I did not instantiate the struct. Okay, we found a bug. Thank you for asking this question about type parameters because we found an issue. I'll finish this resolve type and then I'll go fix that. Okay. So here I want to return a list of types that match the potential name I've given here. It is fun. And I don't care about the arguments at all. So the only thing I care about is for the path name, which is like the fully qualified path of that type, or but whatever amount of qualified it is there any, like, let's look in the current context. And I guess, can I write it? No, I can't write it as a sequence in the list monad. That would be too easy. Okay, so I am gonna do then a fold on this thing because it gives me a maybe list of maybe value in my monad. So I fmap to apply something to the maybe value within the monad, and fold to make it a list. Wait, actually, that's not gonna work if the thing is silenced on the list. I'm wrong. I use this a bit too maybe to list. Oh, that works. Okay, because I don't think the thing inside is a monoid, so that's not gonna work otherwise. And it's on the list for sure. Okay, so that's potential names. Now, what I want to do is for each name in the list of names, I am going to try to resolve that type yes, this is the type parameters. I don't care about them. And so this is going to be resolve name process declaration. Wait. Yes, this is the thing that does a lookup of. This is something that does a lookup of for a given name. Yes, I think. Okay, yeah, I think I can use this. So I can do exactly that. I can do this resolve name with process declaration. Oops. For each name, I'm gonna resolve the name, and the parameters I'm gonna give an empty list because I haven't resolved them because I don't care about them for this specific context. And I have this very special callback which is called process declaration, which is this complicated type here. Basically, the argument can be either a unresolved declaration if it's something in this module, or a resolved declaration if it's something in another module. And the function will work either way. But it's fine here because I will never need to actually inspect the thing. The only thing I care about is if there's no associated declaration, that means it's a built-in thing. I'm hoping to eliminate the case where something has no declaration, but for now that's a built-in type. If it's a type alias, that's perfect. That's a path. But this is gonna give me. No, I need this to give me a maybe value, and then I can do a cat maybes on the result. Is there a traverse maybe? Google to the rescue. Can you see it on the screen? Not exactly. Let me put it here. Is there a function such as it takes an A and a maybe, it returns a maybe B, takes an f of A, whatever kind of functor f is, and returns. Is that just traverse? Am I reinventing traverse? Because if I do, yeah, that's just traverse, right? Yeah, that's just traverse. I'm reinventing traverse. The problem is, I think if I do traverse on a list, it's gonna give me just only if all of the elements are. It's not gonna do a cat maybe. I don't think it's gonna do that. For instance, if I do traverse on using x if x is if odd x then just x else nothing on 1 2 3 I'm gonna get nothing because there are some even values there. Yeah, okay, so I can't use traverse for this. That's fine. I think cat maybes of a traverse, that feels a tiny bit. Could it be like a map maybe of a sequence or something? This is fine. Cat maybes of a traverse. Okay. And so, except, no, here I have the type of this callback. So this callback gives me a maybe value. And therefore, for each name in the list, I associate the maybe path and I cat maybe, and that gives me my list of types that match this name, regardless of the type arguments, regardless of anything else. Now, again, if it's a no declaration for now that's a built-in type, I'll accept it. If it's a type alias, yep, perfect. That's a type, we like it. If it's a constant, that's not a type. If it's a function, it's not a type. If it's an enum, that's a type. And if it's a struct, that is also a type. I'm gonna group them by, there we go. I don't need this pattern matching here because I'm just doing the bare minimum. Okay. And so that should work, which means now I can go back to what I was doing, which was here, which is here I can do matching type is a resolve type maybe of pure identifier. That's the path. That's the only path I have. Okay. And that's enough, and that gives me it gives me something in the analysis monad because I don't need the maybe t there. I guess it makes no difference to include it. Might be easier. Okay, so I do this, matching types, I get this when not null matching types report warning. And I'm gonna change my diagnostic. This is gonna be a list of names. I've used the full path info resolved in those, and here I'm using the name. I think name is enough here because the type arguments don't matter. So I think name is enough. So report warning, and the warning is going to be warning type shadow. Yep. Oh, interesting. Okay. It did a complete that was an autocomplete that was surprising. And so the shadowed types are those matching types, and I guess for all of them, I guess I could change my function earlier because I only care about their names. So maybe this only gives me a list of name. So this is now a maybe name. And in all of those cases, this is path info, the path name. Which means I could go back to doing what I was doing here. Deconstruct the path and just return path name. Okay. So now matching types is the correct type, and now I only need the name of this thing that is currently shadowing the others. And that is this name here. which means I can use it here in the warning. And I guess I could do, instead of a when not null, I could do a unless null, and then return pure identifier for the path and pure type name. Perfect. I can remove this warning. Are there contexts in which I will want to not have this warning? When I have nested type parameters, perhaps? I don't think so. I think it's fine. Okay, so now that means there's a few places here I can rewrite this as being with type parameters. Oh, does it take... It takes the name, yeah. Okay, perfect. With type parameters, this name and the alias parameters. And then it takes a callback, which is what do we do when those type parameters are in scope? And what we do is this. Oops, wrong copy. I meant to copy this. With type parameters, and here those are struct parameters because this is a struct, and I can remove all of this. Ah, yes, this is a use of a lens. Would I want to make that a bit more explicit? I think it's fine. For an enum, there's no type parameters, that's not required. Type matches, I think I'm going to move it to another function, another group here, because I think it's more of a helper than part of the analysis. There you are. Analyze enum, analyze constants do not have type parameters, so they don't need that. Their types might, but that's going to be a resolve type, I suppose. And they might not even, actually. That would not make sense. Okay, so that's fine. Analyze struct fields. Okay. This is probably where I'm going to need to do that for the expressions. Okay. But finally, I can do it for analyze function. I can remove all of this. And make it this. And it is function parameters. Perfect. So this should already compile, hopefully. Let's make this compile. Even though we haven't made a lot of progress on the function yet, we've cleaned a bunch of things, added the first warning and everything. So let's try to compile that. And then we'll try to figure out this thing about the thing that doesn't work at the moment. Oh, I have two of them. That's because I renamed report warning here in the type, but not in the actual implementation. There we go. This has to be a unit. Let's call go. Couldn't match type non-empty name with name. Oh, actually, maybe fold was correct. Actually, I'm going to do a stack GHCI, which is not going to compile, and that's fine. I don't care. Okay, I just want to have a few things in scope. What's the type of fold? It requires something that is a monoid. Is non-empty a monoid? It's not a monoid, it's only a semigroup. Because of course you can't have an empty, non-empty by definition. Okay. I guess what I obtain here is a maybe non-empty list, which is basically semantically equivalent to a list. I don't know if there's an easy way to make a maybe non-empty into a list. I'm just going to do it manually, even though that feels gross. If it's nothing, I return a list, an empty list. If it's just non-empty, I return to list non-empty. Which I guess is the same thing as doing a maybe empty list, ne2 list, f mapped into this. I don't know why I was doing a bind there. There was no reason for that. Okay. Okay. Variable not in scope. Path. Yes, it is now path name. Resolve type maybe, not resolved type maybe. Couldn't match. Oh, because all of the others do some deconstruction of the thing, but this one doesn't, so this has to be struct params info. Is that the last errors? Nope, it is not. Oh, yes, I still have a for underscore, which will return nothing, which means it doesn't return a list, which means this doesn't work. This requires a path info. Do I actually need the path info, or do I just need... I just need the first argument, which is the name type at the time it's passed, and when it's passed, what it is a path, which is a type alias for, if I remember correctly, yeah, I think I just need a path. So let's do that. Resolve type maybe, where are you? You are here. You take not a path info passed, you take a path. Which changes basically nothing, except now this should be fine. Aha, a shadowing error, which is kind of funny. Yeah, of course, that shadows the existing path name. I'm just gonna create path. Type name, shadows an existing binding. Okay, that's compiled, which is good. The test still compiled, which is good. Perfect. Let's go back to our test module. So first, this should already... I've removed it. Type C of T t equals t, that should no longer be allowed. Error duplicate type parameter because the C declaration contains t more than once. Perfect. So now this works. And if I remove this and I make, I can't use something that uses those, but I can at least check that they compile. Yeah, okay, this still compiles. B is indeed a foo of int. Perfect. Now we need to figure out why this doesn't work. And that is because I am referring to a struct that contains type parameters. So let's go back here. Let's go to our constant. Let's look at struct expressions. So here, resolve type struct info, I resolve a struct for the given path. So here, foo of int or something like this. Could I omit? Could I omit type parameters based on the... Because the name should be enough. Huh. In the context of an expression, I could probably make it so that type parameters are optional. For now, let's not. It's going to be easier without. Aha, here I have this analyze struct field. And I think that's where it's wrong. So what I'm doing is, okay, I have encountered a struct expression. I have the name of the struct on the left-hand side. I have a bunch of fields within. I analyze the fields without checking anything. You tell me that the field X is that, the field Y is that. I just do the analysis because they're just expressions that can be analyzed. I don't need anything to be in scope for this. However, when I do the analysis of struct fields to make sure that like the fields you gave me match with that thing, I am going to need to know the type parameters. So this is where it's wrong. Let's do it like this for now, where I use the type parameters and I'm expecting them to be explicit. In a second time, I'll try to see if I can make it so that they can be guessed. So for now, analyze struct fields, which was this function here. What I need to do here is extremely similar to what I've been doing in my with type parameters function, except here I need to basically treat them as names that point to another type because they have been given to me in order. So I'll need the struct info resolved. Okay, I'll need that, which I'll need to give here when I'm doing the analysis of the fields. Struct info, which means I don't have to give the struct values directly. Oops. which means I don't have this parameter anymore. Do I have to re-resolve? Do I have to instantiate the structure? This is the struct values of the struct info. Although I guess I could actually just struct info and deconstruct it and just do that. Okay. Reference doesn't exist anymore. I do have a type substitution function. Where is it? I think this will not work. This is basically saying, hey, actually type T matches to that type. And in a given type information, replace the whole thing. But it's for path info. I still think that's correct. Okay. So what we have to do is we have to build for each we don't do it here, I think. Haha. We don't do it here because the type that I return here when I am doing this analysis of the struct fields is the result of this expression of the struct construction expression, if it is successful, is an expression whose type is being carried along and needs to be the correct type. So the fixed type, not this resolved type I have here. Wait. I think the resolved type is correct. I think the resolve type is correct, but I think the resolve struct will do the type substitution. Let me check that. There's an easy way to check that. If I have here this always being an int instead, this should type check because here there's no t mismatch. It's not going to be a problem. So here it's going to expect an int, find an int, and return this. The question is, will it complain that this expression is of type foo of t and therefore doesn't match foo of int, or will it be happy? It is happy. Okay, so the type substitution already happens in the resolved type. That's good to know. Does that mean that I should, as a result, do the substitution in the types in resolve struct? Let's see what I do in other ones. Where do I do substitute types? And type aliases here, that makes sense. In type aliases here as well, that makes sense. But both in resolve type and but resolve type only gives me the path, so the path will be fine. It's for the struct info here. I think it's for resolve struct. It would make sense. It would make sense here to do the substitution on the structure itself. Give me a minute to think about this. Because I'm also thinking of like, do I want to handle not giving the type arguments? Which I think is possible, but it just means here, if type arguments are not given, that means I need to return the unmodified struct the way I do at the moment. And then where it gets complicated is it means for each field, I will have I might leave it as a to do because it's gonna be complicated because it's basically for each field. If one of the fields is like vec of t, for instance, and I get vec of int, I need to do a diff of the two types to figure out exactly for each type parameter what type it matches to, and I need to do that for all fields. And then I need to do for all fields, are all the types consistent, and are all the types identified. But after all, that feels doable. It's going to be complicated, but it feels doable. And there's no reason not to do it. So let's do that. I'm going to do something here. Here, I'm looking at like how many type arguments were given and how many are there actually. I'm only going to do an error when the number that is given is not the one that's expected and is non-zero, meaning if you don't give the type arguments in a struct expression, that's fine. But if you give some but not all of them, that's an error. Okay. Wait, I'm in the wrong part of the code. What am I doing? Yes, it is here that I want to do this. Type aliases do not have the luxury of not specifying the correct number of type arguments. And here I am going to need to do the substitution. And I think it's going to be complex enough that I'm going to make it a separate function. Okay. So if null actual I will instantiate that struct. And do I want to persist instantiated structs for a given type in the scope? Or is that a cheap enough operation that every single expression that does it, I can do it there and it's fine? Do I want to maintain a cache of that, basically? For functions, absolutely. Too complicated to do otherwise. But for structs, it's just a matter of replacing a bunch of type parameters. It's trading memory for CPU as usual. It doesn't feel like a bad idea to do it. I could do that. Okay. Which means if I want to do that, I will need the full path info, which is path, which is going to be my key for the cache. Okay. And the result after this will be the path and the instantiated info. Okay. So to instantiate a struct, we are going to need the path, which is a path info resolve, which is going to be our key in the cache map when we do a cache for them. We're going to need the struct info resolved, which is the struct info with all the types in them at the moment. And we are going to need the list of identifier, which is the list of parameters. Wait, that is incorrect. This is not a list of identifiers, because at this point, the path params have been, also it's not actual, actual is a length. So that's wrong. This is path. Oh, it's the parameters in the path. It's already there as per the path argument. Perfect. So I don't even need to do that. So here's going to be the result instead. And those are path info resolved, which means they are a name and a list of types, which are themselves path info resolved. So it's a list. Yeah, it's a list of basically name that uniquely identify types. Okay. Okay. Perfect. So the result of this will be in our monad. It will be a new struct info resolved. Now I'm going to make a quick change. To our monad and to the context. Which one is the state? Which one is the reader? And I think context is the reader is the info, writer is the diagnostic, context is the state. Context struct cache, which is going to be a hash map from path info resolved, which means we're going to need to make sure this is hashable, which it's probably not, to a struct info resolved, which means another empty map in the initialization of our context. Yeah, partially applied struct arguments. No, we're not going to support that. I mean, I guess we could, right? You match the first ones and then you leave the other ones undecided. Technically, we could support, with the way I'm planning to do this, we could do that, but that feels extremely gross. We could do it the Rust way with underscore meaning Oh, I'm tempted. Oh, I'm tempted to do that. I think I'm gonna do that actually. Thank you for the suggestion of partially applied struct arguments. We're gonna add more things to the language. Okay, so I have the cache here. That's done. The only thing is I think path info resolved is absolutely not something that can be hashed. So we are going to have to make it hashable so that it can be part of a hash map. What is going to be required for it to be hashable? Names are hashable. And the path, yeah, that's just a name type is the only thing that's going to be required. I think for this one, which is so specific, I'm going to write it not with a constraint alias, but just as is. So what I need is hashable name type of P. So therefore, what is the name at a given phase? If that thing is hashable, then the path info is a struct that contains... I don't think I can make it hashable actually by deriving because it's not generic. So I might have to write it myself. I could derive a generic instance, but that feels gross. It feels unnecessary. Not gross, unnecessary. But so if I know how to hash a name type, then I know how to hash a path info. How did I wait for a name? I made it generic and I derived the instance of hashable. Okay. So I am going to do the same thing. If a name type can be hashed, then the path info can be hashed. And the only thing is I'm going to need deriving generic so that it can generate this instance here for me. Okay, that was missing. That's done. Let's go back to analysis. So here we're going to do a very simple thing, which is going to do a cache lookup. Do I have functions to just like insert the value if it's not in the cache already? I don't think I have that. I'm just going to do it manually. Uses context struct cache, is it not? Struct cache, there we go. Typing is hard. Context struct cache. Why are you not completing this? It's fine. So I'm going to use this, and what I'm going to do is a lookup of the path. And there are two possibilities. If it gives me just a result, that's perfect. I guess I could even do it with a on nothing m, which will return the value inside this thing if it is just. Otherwise, if it's nothing, execute this monadic action. And this monadic action is going to be the one that does, except no, I don't want to do this because... No, it's fine. I just need to make sure at the end here, I'll have a result equals whatever, and I'll have to make sure to do uses context struct cache, or rather, context struct cache modified with insert path result. There we go. Pure result. That's going to be the end of this expression there. Now, what do we do here? If we go for the route of partially applied struct arguments, that means I need to recognize underscore as being a special type. That means underscore can never be declared as a type. Which at the moment is perfectly fine, I think. Yep, that is perfectly fine. That means I have to reject the name underscore on its own because it has a special meaning. What does Rust do? If I try to say that I have a struct name underscore, what do you say about that? Expected identifier found reserved identifier. That's fun. Yeah, I guess int doesn't exist in Rust. This is going to be i64. Yeah. Okay. So I guess we could do that. I guess for every declaration, I could check that is not a reserved identifier. Actually, I should do that already because at the moment, I think I can do struct int. Aha, except it's gonna tell me that this is ambiguous, but now I would have to do main int here to disambiguate which int I'm talking about. But I think with this, oops, and I need to comment this out as well. Yep. I can declare something named int, which happens to be a struct name int. That is a bit of a problem. Okay, so let's stack another thing to do on the list of things we have to do today that we figured out. Great. I'm gonna go to built-in and I want to make reserved, which is gonna be a hash set of identifier. And reserved is gonna be a hash set of identifier, which is gonna be s from list. I'm gonna need to import a hash set in the scope. The type hash set is already in scope. Yep, yeah, I'm shadowing keywords, which is why I'm adding this thing on top of the scope of like, we need to be able to prevent that from happening, which means then I can also include underscore and I can go back to the instantiation of structs to make underscore a special case where we will recognize that it is a valid thing to say in that context, where we will ignore that type in the resolution to make partially resolved structs. Okay, so I want hash sets, and this is going to be a list that contains so that's the funny thing. Int will be whatever the Piètre interpreter underneath considers to be an int. As in, Piètre underneath is a stack-based language in which each stack is like one cell, whatever a cell is. And I think npete, which is the most common interpreter, uses a machine-sized int as the size of a cell. I think I've made the choice to say in the documentation of this language that basically I'm assuming that it's always going to be a 64-bit int, but in practice that assumption might be wrong if the interpreter actually uses 32. But my assumption is 64 everywhere because the interpreters I've seen are usually machine-sized int, which tend to be 64. So I've made the case to say my language assumes 64, and it is such a small use case that I can make such a big assumption, basically. But it won't be an issue for anything that doesn't overflow or anyway, so it should be fine. Okay. I want to get the list of identifiers, which is if I get from this list, it's a list of path. So it's going to be for each element of this list. Although this is a built-in, this is the types, I'll have built-in functions at some point, so I have to be careful. But this is, actually, I guess the reserved identifiers will be, no, I guess functions can be, maybe not. Maybe we don't want to allow shadowing special functions of the language. I'll think about it when I add functions. So for now, for each of them, I take first, which is the first element of the tuple, which is the path. And now I need the only element in it, despite the fact that this is a non-empty list, which is not a partial function. I can do this. I will need import data list non-empty qualified as NE in scope. And that's the list of the names that are reserved based on this. And I will need to add some other special names that I want to reserve. And I think underscore is one of them. I think that's all for now. So I could actually just do it for now with underscore. Okay. Perfect. Let's go back to our analysis. Now, where do I need to do that? I need to do that in every top level declaration. And I need to do that in every type parameter declaration, I think. Like the name of something that I declare cannot be a reserved name, and any of the type parameters at declaration time cannot be one of the reserved names. I think that makes sense. Okay. So that means at the stage where I have this with type, where is it? Here. Here, I also need to do a check. I need to check that before I do this, actually. When identifier is a member of the reserved identifiers. I call them reserved? Yes. Then report an error. And that error doesn't exist yet. Error reserved identifier, I suppose. Do I want the name? I guess I want the name. That will tell me in the type. Oh, sorry, I had missed your question. So this is an extension of the language, which I don't remember the name of. Give me one sec. It is package imports. And what this does is it allows me to specify with a string what package I'm importing this module from. For instance, let's say there's like two of my dependencies that have something named foo, like a module foo in them, like list and non-empty list both have foo or something. I could say import list foo, or import non-empty list foo, and it would choose the proper module based on the name of the package. This is a special name, which is the current package. And the reason why I'm doing this is I have enabled another language extension, which is no implicit prelude. The prelude, the normal Haskell prelude, is not imported by default in all of my modules. And instead, I am importing this prelude that comes from this package, as opposed to base prelude that comes from base, which is when I have defined myself, which is mostly based on the base prelude. And if I go to this prelude in this package, it does an import of the base prelude. Yep, it is just this thing I have here for this project. It's not like a open source common alternative prelude. It is just mine that has basically everything from the base prelude except lookup, basically, because lookup is on the association list and it kind of sucks. And I have mostly basically a bunch of other things imported from other common modules, because all of those things are things I use quite a lot, and therefore just by importing my common prelude, all of them are in scope. And I have a few additional things. I have the Blagabell operator just because, for the sake of it, this has followed me for my entire Haskell career. And I have those on nothing things I've been using, which are very useful. I have the same thing for on left for either. I have a pattern for loan for sequence, and I have this union with key M for hash maps. Basically, anything that I think is useful beyond this project goes into here. And I copy this prelude from project to project, basically, because like the gist of it, of like, I want the prelude functions minus the one that conflict, plus a bunch of things in scope, so I don't have to type a bunch of imports in all of my files. A pretty common use case, basically. But yeah, as a result, here I say prelude, and I don't have to qualify the use of hash set, because hash set is included as part of the prelude. Even though I have to like import it qualified here to access the functions, the type hash set is already in scope thanks to my custom prelude. Yeah, finding this extension for the package imports really made this possible and made it a lot better. So go back to here. Yes, I was doing a diagnostic, which is error reserved identifier, name identifier. I guess that's enough. Or do I want to make a distinction between that's a type parameter versus it is a declaration? I think I don't need to do that. I think it's enough to just say in the declaration of whatever, the name whatever is a reserved identifier. I think that's enough. So I think just reserved identifier is enough. The name is the type name, and the identifier is the identifier. Okay. I guess I could hide. I guess I never need the list of reserved identifiers. The only thing I need is reserved. So I could, it doesn't hurt to have it, but I could just instead have is reserved. Which is just, do I keep this as a top level declaration? Will I ever need to go through that list at any point, that hash set? Or do I just make it hidden as part of is reserved? There's no harm in having it at top level for now, I think. I'm just going to keep it. So is reserved is just flip member and reserved. Because member takes the argument first and then the hash set second. So I'm flipping it so it takes the hash set first, reserved. There we go. Okay, and now I can go back here and I can say instead when is reserved identifier. Perfect. And now I can do this for every single top level thing. Oh, I guess I could do it at the top level, actually. I don't have to do it for every single declaration. Instead, I can do when I get there, is it already too late? No, all of them have the all of them contain the identifier for the thing. But do I want to do it at this level, or do I want to do it at the top level? Because at the top level, here I'm doing for each identifier. I think it makes more sense as being part of the analyze series of functions. This is where I would expect most of that stuff to be. And if I ever want to do recovery from one declaration to the next, it makes sense for a declaration itself to fail because of the use, but then yield back to the top level that will go to the next declaration. So I'm going to do it here. So here, when I have access to the name, okay, so what I need is I will need okay. This declaration here is actually a with location. Yeah, that's fine. Okay. And now I can do the same thing, which is when is reserved. And I guess I don't even need to introduce this alias. I can just do that. And not type name, but this name. Okay. I'm not sure why you're unhappy, but something is wrong. Okay. So now we should have fixed the use of reserved identifiers. I can go back to what I was doing, which was the instantiation of a struct. There we go. And now here, it is okay to use a very specific identifier because using int or whatever is perfectly fine. That's normal. That's okay. Wait, no, it's not. Because when I get to that point, I will have already done a resolve struct. I'm here, which means I have done a resolve path, which calls a resolve name and so on, which means I have done a resolve type on the type arguments, which means I have which means at that point I need to recognize underscore as being a valid type for the purpose of this, basically. But crucially, I cannot do that for normal types. It's not okay for underscore to be the return type of a function or the type of a constant. It is only allowed in type parameters. But the good news is, no, it's not. When do I call resolve type? As part of the type arguments, as expected. When I know that's fine. Okay, so I need to be able to say, I need to be able to differentiate underscore is valid in this context or it is not. Okay, I'm gonna make a change. I think I know how to do that. First, I'm gonna introduce underscore as being one of the types here, which happens to be do I want to introduce a pattern for it? I guess yes. This is not a type. This is a placeholder. Do I want to introduce a new name for it? I think I do. Placeholder. Which will conflict with this. Okay. Which I guess in this case is just placeholder. Which means I can remove the underscore here. Okay. So now underscore is recognized, but by default, resolve type needs to not allow it. I think to avoid using a boolean, I'm gonna use a very small type, which is type resolution, which is gonna be a small enum of allow placeholder, forbid placeholder, which is basically a boolean. But it makes the arguments to the function a lot more readable. I don't think I need anything more than show on this one. Which means now resolve type takes a second argument, maybe a first argument actually, which is gonna be a, how did I call this? Type resolution option mode. Type resolution mode. And now that means that when I find a type, Actually, what's the error that Rust gives for this? Because if I have, it's probably the same, right? Because if I do let x equal, which is a vec of I64, and I do vec of underscore new, it's perfectly happy with this. It's going to complain about x not being used, but that underscore, no. Oh, because my syntax is wrong, as usual. Okay, so that's valid. When would it be incorrect to do so? Would it be incorrect to do it the other way around? No, it's not incorrect. Interesting. So I guess the problem is just... Actually, I think that's valid if this is explicit. It is. So could I make a function that returns underscore if it is extremely clear about what it returns? Would Rust allow this? Okay, the placeholder isn't allowed within types on item signature for return types. Okay, so it is very specific when it's not allowed. I think at this point for me, the only place where I want to allow it is within expressions. I think everything that requires a type, I guess for constants, I could try to do that as well. One thing at a time. One thing at a time. So for the help of the I am tempted to change something I have done here. Wait, didn't I do it here? I did it here. I don't think it makes sense to have it here. Do I want it here instead? I think I want it here instead. But I think I'm going to change it so that when I forbid the placeholder, there's going to be some arbitrary text for now that's going to tell me what context we're in, so to say why we're not allowing it, basically. Okay. 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 Now, here, this is one of those cases where there will not be an associated declaration with a type. And I think that's always going to be the case for this. So here I can do a case of the path name. if it's placeholder, and I guess if we are in the case where this is a placeholder and the mode is placeholder, how did we call it? Forbid placeholder. With a context string. Then I can report an error. I don't have a diagnostic for it. This is an error placeholder. The context is this. And otherwise, the other, it's not the placeholder, or it's not, or it's allowed. We just return the path. Okay. Now that means every single call of resolve type is going to be one where I want to decide, is this allowed here or not? Shit, it's more complicated than I thought, because it's not... It's not that the type parameters are allowed, it's the whole type is allowed to be underscored in some contexts. Okay, so it's not a matter, of... So that means resolve name needs to also take the mode as an argument. Because resolve name... Sorry, not resolve name, resolve path. Because we do the resolution of the types of the path of the type arguments, and therefore the mode needs to be given there. Then okay, that means every single use case of resolve call site of resolve path and resolve type will need to be changed. Let's go. That means every single... No, because resolve const value, that's something in which underscore would never make sense because we're not expecting a type. That's easy. This is forbid. Actually, this is allow, because that way, since it's never supposed to happen, if we encounter a type in the first place, it doesn't matter. That's just, we're trying to get a type. I guess I could use a special case for this to make more sense. Well, it's a type resolution mode. It only makes sense in the context of a type. Yeah, so it can just be... It could be a maybe, but I guess allow is fine for a context where it doesn't matter. Okay. Resolve type maybe does a resolve name. In this case, this is for trying to figure out if a name is in scope. I should allow it. But we are already rejecting it anyway in the case where it matches the identifier because we have the detection. Okay, so that's fine. Resolve struct is only used in one case. It's used in expressions, and in expressions, it is allowed. So that means here, except it's only going to be used for type parameters. However, when we try to resolve the struct itself, underscore would not be a valid struct. Therefore, okay, I think that's fine. The only thing here is perhaps I want to make a better error message here when I didn't add equality. This when path name equals equals, that's the wrong one. That's not where I want to do it. This is on name. It already has equality. Perfect. When path name is placeholder, I can do the proper error placeholder or whatever it's called. I think it's error placeholder. And the context is going to be a hard-coded text for now. I probably will want to have an enum for this at some point. But struct name in struct expression. Okay. Otherwise, we fall back to this one. Perfect. Here I have some for resolve type I actually don't go. Fascinating. Okay. I guess that makes sense. Okay, where else do I call resolve anything? Resolve type, maybe that's fine. Resolve type in a type alias. Is that gonna be allowed? No, that makes no sense there. It has to be fully explicit. Therefore, this is a... Oops. Where was I? This is a forbid placeholder, and with type alias value context, which at some point will be an enum instead of a string. In the definition of a structure that makes no sense. So this is going to be traverse with resolve type. I'm going to rewrite it at traverse.traverse of resolve type something of info. And this is forbid placeholder struct type alias declaration. Struct fields declaration. In the type of a constant, I think we want to allow it. Because a big thing of the language is it's going to be very, very rare for something to be ambiguous because we don't have any int types, we don't have floats. A lot of things will be extremely non-ambiguous. So, because like, yeah, our built-in values are Boolean, int, character. And we'll have vectors at some point, but as a result, since every single value we encounter is either a bunch of numbers, that's an int, a character, that's a character, or a string, it's a string, or a boolean, and otherwise it's just a composition of structs, and structs are always explicitly named, every expression will have a pretty explicit type. There's never going to be ambiguity on types, which means I can just say constant is equal to underscore. It's always going to be possible to figure it out. And here, I'm going to want to do the smart thing of type matches. Wait, why do I do type matches here? Constants can't have type parameters. This type matches thing is only for the case where I want to compare using, I want to deal with the possibility of a type argument. For constant, it makes no sense. And I think for most of expressions, I just use equal on the types. Type matches. Yeah, I don't choose anywhere else. There is another bug I've just realized. Looking at this, let me go to my main again. Let's comment all of this nonsense out. If I have an enum color equals red, green, blue, let's say, and I have a constant of type int, at the moment, if I do red, it's gonna complain. Because it's the wrong type, red is not an int. But I think if I do 1 plus red, it will compile. Yep, and it tells me that that value is 1. And that's because I've just realized that in my constants, in here and for all of the binary int expression, I don't check the type, I check that I have a int underneath. And enums are represented as ints. So I think for int expression, I'm going to do the same thing here. which means I'm gonna do it differently. I'm gonna do that x, or left-hand side, is the result of going recursively on the expression 1 and doing a case where when I get a typed expression of type int type with an int literal expression x, that's perfectly valid, and that's x, thank you. If I get literally anything else, which is therefore a type expression, type name, and a value I don't care about, then type name might be a conflict exp name, exp type. Wait, that's also going to be a conflict with the lens. E1 type. There we go. Error, we expect an int, we got this. And right hand side is going to be the same thing, except it's going to be on E2. If it's an int type with an int literal expression, we return that value. That's perfect. Otherwise, if it's this thing, we return this. And then finally here, we don't have to do all of that stuff. We can just do pure int expression. There we go. I can probably rewrite this to be the same, because I think it's a better way of doing it. Bool expression here. I think generally I can probably do a int to boolean on this. Yep, E1 needs to be a boolean type, bool literal expression x, otherwise wrong type. I was expecting a boolean, I got this. Likewise for this. Perfect, and all of this can go away. And I'm gonna copy this. I think I need to do something a tiny bit different, because at some point the plus operator will be different and will allow for like concatenation and stuff. But I think I can just copy the pattern for now and change it when required, because that pattern is, I think, better. Okay, and I think the difference here is now I'm going to include the type as part of the return value here. Because this stop one will be, hey, I'm expecting a int or a string on the left-hand side of a plus, but I got whatever this thing is. And I'll match the other cases that are correct. Here, likewise, I need to say, hey, this was valid as an int. And here I need to do an additional when, so this is going to be LHS type, LHS value. Oh, I can't do this because it will depend. Because it will depend. It's not, the type isn't always going to be the same on all branches. Therefore, I have to keep this as an int literal expression. That sucks. because it's basically indistinguishable from this. Ha. So this is instead LHS equals this. Then it is a case LHS of, and in this case we do nothing. In this case we report the error. Then it is here the same thing. Case right hand side of. We do nothing in this case, and we report the error otherwise. Now, when the expression type of the left-hand side is different from the expression type on the right-hand side, report error wrong type. I was expecting the type on the left-hand side, but I got the type on the right-hand side. And now I still have to do another case of left-hand side, right-hand side. But in this case, I only have to care about, because here it will only be int expression if they're both int, or string expression if they're both strings when we allow strings in this. But every other case will have been handled. Therefore, I can match. I can explicitly say this is an int literal expression x, int literal expression y. The result is pure int expression fxy. Any other case is impossible, and an internal compiler error. That means that the test we've made above was just incorrect. Okay. Is it a bit sluggish, or is it just me? No, the CPU is not. Okay. Okay, so that's better. And that means when this all compiles, we should be able to test that, like, doing plus on enums no longer works. Perfect. Where was I in all of this? I was going through the resolve types. Is there more? Yes, here I have this type matches, which is incorrect. So here, what I'm going to do instead is I'm going to update resolved type. I'm going to do this, and then I'm going to do a case. No. No. No, I'm not going to read that like this. I'm going to do it differently. I'm going to do it with a good all if then. Arguably, instead of that, I could just make the type arguments of a constant. I could make the type argument of a constant non-required. Maybe I don't know, because the reason Rust makes it required is not that like it's necessary necessarily. It's just because it's good documentation, right? 'Cause I don't think const equals 3 is allowed, right? Yeah. Oh wait, I'm an idiot. That's constant foo underscore. Yeah, it's not allowed within the. I didn't. Yeah. But it's allowed within the type arguments is the thing. So because I think const foo there would be a vec of this. Let's try actually. Struct foo. Maybe not actually. Maybe I'm wrong. Foo of t, which next is a t. If I have it's not allowed at all. Okay. Which I guess is just because, like, yeah, for constants, it's for top level declaration, it's better to just not have underscore there. But declaration for yeah, also because it means if you have an underscore, you're forced to do analysis of the value to know the type of the thing. If you don't, you can just look at the type and have that information immediately without having to do any deep lookup. That makes sense. Okay, so I think that means forbid placeholder there, and that's a const declaration. And here, that's gonna be the same thing, except I can do this as a when and do it with differences because I don't need to handle type. I don't need to handle type parameters here unless I decide that actually I want to always do it with the function that checks for type arguments so that I don't have to decide which equality function to use based on the context. I don't know. I think this is fine. Okay. Okay, so we fixed that. And I think here, this is a resolve type with forbid placeholder because we are in the context of a function declaration. Okay, now that we've done this, we can go back to resolve struct will allow for the placeholder in the parameters, not in the name of the struct itself. Which means here, when I do instantiated, some of the name of the arguments in the path will be potentially placeholders. Oh, for constant casts as well. Resolve type, forbid placeholder, cast expression. There we go. I'm sure there's a bunch of other resolved I've forgotten about that will complain at some point, but that's fine. Okay, so now I am going back, I'm depiling all the things from the stack. Let's go back to instantiation of a struct. So, what do we have? The path here contains two things. It contains the name of the struct we don't really care about in this context, and it contains the have I usually used I usually use a space, and the path arguments, which is the type parameters, which is what I'm interested in this case. What I want to do here is to construct a fake struct info that has is like what the struct info would be like if the types had been replaced. And I think I have to do it type by type. And I will obtain, by doing this, the list of new type arguments. And if none of them are placeholder, the new list will be empty. And otherwise, I'll have the new list of types that need to be provided in this context, or that need to be checked in this context. Okay, so this will look like, I'm going to do the thing I had earlier, where I do this, and I go back to the AST here so that I have the struct info which is there, perfect, so I can see what the struct info that I'm dealing with is at all times. Perfect. And here I am going back to instantiate struct. So what I'm going to do is, for each of the path params that I have found, I am going to actually, they're gonna need to be in order based on the declaration order of the struct. I have already checked at this point that the number matches the number of elements in the that it matches the number of elements in the declaration, so I know the number is correct. Therefore, I can just zip this with the struct params of the resolved info, which I am tempted to decompose as struct info here like this, which is therefore just the struct params. There we go. So now I'm going to iterate on each pair of, and I'm going to iterate in the other way around, expected, provided. And now for each of those, I'm going to want to return something that indicates whether that type is still needed or not, basically. So I will probably want to construct a new list of type parameters. And so that's going to be something where at the end I return maybe of the identifier here in the struct, in the expected. So let's say at the end it's pure just provided because it was a placeholder, or nothing if it was not a placeholder. And therefore, here I can collect new params by doing a cat maybes of this for loop thing. And the result will be a struct info where the name will be the struct name unmodified. But I will want to change each parameter that is provided will need to be replaced throughout the struct. Therefore, this is not going to be a for, this is going to be a fold. What's the type of fold M? Is it the one I want? I never remember if it's the one in control monad or in data foldable. Okay, so for some accumulator B, a value A, and a function overall that returns the new accumulator within some kind of monad, start accumulator, traversable, or foldable, I guess, of A. So this is what I want. I am going to want to do it's going to be a fold M. My function is going to be named go, and I'm going to make it as a subfunction in this function. My start function is going to be, I think, this base struct info that has not been modified yet, except I think I am going to set the parameters. What's the proper operator? I think it's this one, to the empty list, because I'm going to reconstruct the list as I go. So it's the base, but with struct params set to nothing. And the list of things I'm going to do this fold over is going to be, as I was saying, this zip of the parameters that were expected and the types that have been provided for them. That gives me the new resolved struct info. I add it to my cache and I return the result. There we go. And now I can declare go as being a function that takes the current state of the struct info, a tuple expected provided, which is our element in the list of the zip here, and returns an expression in the monad here in which we do everything, in which we have done the work of substituting this template parameter with this provided value. And here it's gonna depend a lot on if we provided a placeholder, provided is a, so this is the path name of provided. If the name is placeholder, the lack of declarations on things is a bummer, because it means at the moment in the places where underscore is allowed, someone could do underscore with type parameters, which I guess, no, I don't think I want to handle that. No, I think underscore cannot take type parameters. If you're specifying type parameters, you specify the type. But that's because at the moment, all of the verification is based on finding the declaration and looking at the number of expected parameters in the declaration. And for things that do not have declarations, such as built-in types, that check is not performed. To do later. I'm not going to add more and more things to the stack. I'm already too deep in the stack of things today. So let's do this instead. So if we encounter a placeholder, we do not make any modification to the types of the values in the struct. They are still going to be parameterized by that type T or whatever, because we did not provide a type for it. Therefore, the result of this step is going to be current, on which we are going to modify the struct params to add, using the semigroup instance, a new value, which is expected. There we go. This is put in the monad. Anything else, if it's not a placeholder, then it is a valid name. Could I check here? Would it make sense here to check whether the thing that was given as an argument is a type parameter? Actually, I guess that's possible. That's possible in a function parameterized by a type T. I encounter a struct expression in which the struct is like T. I have to check. I have to perform this substitution there, I think. So that means I don't have to check whether this is a type parameter. I do the same thing anyway. And what I do here is that I'm gonna collect the new values by doing a for on the current struct values. Will those shadow those? And will that be a problem? Possibly. We'll see what the compiler has to say. So for each value in the fields of the struct, actually, why am I not allowing empty structs? I guess because they make no sense. So for each of them, I have their name, and I guess I'm gonna call this field name, field type. For each of them, what do we do? Is it just a matter of calling substitute types? It is, I think. So instead of doing this one by one, I could instead collect for each type. Yeah. I'm gonna rethink this. I don't think I need a fold anymore. I think I can do something a lot simpler. Because what I need to construct two things. I need to construct the new list of type parameters, as in all the things for which I provided placeholder, and I need to construct the hash map of type to type name to actual type. So this is going to be mapping and cat maybe's new params is gonna be the result of doing an unzip of a 4 of a zip of this thing. Cat maybes for this, and the mapping is gonna be a simple union. There we go. Of unzip of for those things, which are indeed expected provided. I can copy this logic here. Okay. This result goes away because we're going to do something very different. And this go function goes away. Okay, so if the provided name was a placeholder, this isn't even a 4. This is just a simple map. There is no longer a need to do anything complicated there. To the point where I could... No, it's better to do it once for the zip, I think. So this is no longer in the monad. So this is a let. I can do it with not an unzip, but a partition either, I think. Which I think makes more sense. Which, given a list of either A, B, gives me a list of all the A's and a list of all the B's. Which is exactly what I want to do here, because I want the mappings on one hand and the new type parameters on the other. So I will want to do a from list on the left-hand side, which is going to be our mapping for this. New params isn't going to require a cat maybes. This is no longer going to be a thing in the monad, so I can just do a do in the list monad instead. I can get my expected provided from the zip here. I don't need the unzip anymore because I have this partition ithers. And I can do this again. And in the case where I find a placeholder, I want to report the identifier as the new parameters. So right of the expected. Otherwise, if it's literally anything else, then I want to provide in the left a tuple of when you find the name t, you want a mapping to this value that has been provided. We do this for every value. That gives us a new list of either on the left the mapping, on the right just the identifier. We do partition ithers to get the list to split the two lists. Mapping gives us a hash map. New params is the new list. Okay, now The only thing left to do, and that's not a small one, is going to be the new values, and the new values is going to be, I'm gonna apply the lens. Well, I already have the value. I don't need to do that. So it's gonna be a traverse on the list, on the struct values, which is a non-empty list of tuple identifier path info, which is a type. I'm going to traverse this list. On each pair, I'm going to do a second traverse. And on the actual path info, the monadic function I'm going to apply is going to be substitute types. And it takes as an argument the mapping. And our result is going to be base on which struct values. I'm going to use the lenses, but at this point I should just recreate a new struct. It is going to be a struct info with the struct named unmodified. Do I change the struct name? Do I change the struct name? Because it is no longer the same struct. It is a weird struct with new type arguments. No, I think I keep the name intact because the name points to where it was declared, basically, and I think it's good to keep it that way. Okay, so the name isn't changed, but the list of parameters is now new params, and the list of values is now new values. Okay. And now we have instantiated the struct, which is used here in resolve struct. I guess this if null actual is not actually required, because if the list of things is empty, the zip is going to be empty. Oh, but it is useful because it means I avoid creating a cache for the struct when the arguments are not important. And I guess I could also test that I'm not creating a cache and not doing the substitution when all of the arguments are placeholder, because that would be useless. Yeah, there we go. There's no point in doing the instantiation and using the cache if all of the things are placeholders, so I simply don't. Yes, there's a lot that goes with generics. Do I regret making generics part of the first iteration of the language? I don't think I regret it per se, but it was definitely a choice I've made there. But I think my reasoning with it was, if I didn't have generics, it would be too easy, and therefore it would not be an interesting project. maybe I was wrong on the too easy, but it's definitely more interesting with the generics. My reasoning was, and I think that one still holds, that given that there's never any type ambiguity in the language, it makes resolving types a lot easier. I never have to worry about like this thing could be any of those possible types, given the way I'm doing things with the C++ like instantiation. That makes a lot of things a lot easier. And as a result, I think it's doable to have generics in the first pass like this. But this is going to be a long project for sure. Okay, so now I have instantiated structs. I can go back to, at long last, this thing here. I'm tempted to do this check first, just for readability. Okay. And I think I'm going to do the thing I did earlier. I'm matching 0 elements, and I'm then going to match more than one element. To then match one element. That way I have the good case here at the end. Which means I can do more things if I need. Okay. And now this actually returns, because this needs to return this needs to tell me this needs to give me the new version of the struct info, because this needs to check. Because if I have any placeholders, if I don't have the fully qualified type, then I need to be able okay. So here is an example where I'm using the difference and I should not be using the difference. Because that's one of the many places I am almost tempted. I don't think I need hashable for type maps and everything. So I don't think I can easily make use of equal a warning or something like this. But I don't want to allow arbitrary comparison of path info. I don't think I want that. I think I want to always using in any situation where one of those could be a type argument, and type argument could be whatever, and therefore I have no way to check. Okay. Reference doesn't exist. This is now struct params. No, struct values. I'm thinking. Sorry, I should think out loud, and I'm thinking rather than just still motionless on camera. I am thinking, can I use the function I did at the very beginning of this stream to put the name of the type parameters in context so that they can be used within the scope to resolve each field? And I think the answer is no, because even if I am in the case of a struct foo with a type parameter t, within the context of an expression that creates a struct, t cannot appear. T doesn't make sense. So no, I cannot use that. It only appears within the field, and therefore it's only used for field resolution. So because the name of the type will contain type parameters, so that's fine. What I want to do here is I want to collect for every type that is unknown at this point, which would be every single type that appears within every single type that still appears within the type parameters of this struct info, which might be none of them if all of them were provided, which will be all of them if none of them were provided. I want to construct a hash map from that name to a list of possible types this thing could be. And then I have to check, one, all type parameters appear in that map, and two, all type parameters appear in that map, and two, all the types that they correspond to match. Okay. Okay. So I'm gonna need a type diff function, basically. Okay, so I have type matches somewhere up there. There we go. Now, I'm going to want to do something else. I'm going to want to do a type diff. Given two types, which is like path and type parameters, I am going to want two that have been resolved. So I know the number of type parameters will always be correct. That's never going to be an issue. I am going to want to return a list of tuple of path info resolved, which will be this thing on the left hand side matches this thing on the right hand side within this type. Okay. And that is not going to be too complicated, hopefully. Here, I want to use equal equals because I don't want to allow type equality on type arguments, because if I am in a function foo with a type parameter t and I'm in a struct and the thing has a value of type t, I want to surface that to the struct to know that its own argument is actually this type parameter here in another context. So that means that here, if the type name of P1 is different from the type name, that's path name of P2, then this function returns a tuple of like, yeah, those two types are different. The end. Otherwise, if those two names are the same, then the diff has to be done on the parameters. So this is a concat map of uncurry type diff of zip path params P1 and path params P2. So basically, if I have, say, vec of int and vec of char, the names match. Therefore, I go on the type parameters. I have int and char. I can say then, therefore, hey, I have this tuple, int on one side, character on the other. Okay. Now, with this, when for a value there is only one identifier provided, which is the good case, it's neither missing nor duplicated, I can compute a type diff. Well, between field name, field type would be much better name for this. So it's gonna be on the left-hand side. I'm gonna want, what does make sense as left-hand side here? I want to do a mapping, so on the left-hand side, I want the reference type, so I want the field type, and on the right-hand side, I want the type of the expression. Now, what I'm going to do next is I'm going to iterate on that diff from list with union, and I am going to look at two things. If the only case I keep, the only case where I allow the types to differ is when the type on the left is a type argument. So when the path name of the left-hand side is type argument, type parameter with a param name, then that's valid for them to differ because it means I need to infer the type, that value for the type based on the expression. Therefore, I will return pure param name. This identifier will actually correspond to this type, which is actually a list because I'm going to keep a list of all of the types that I have found because I have to check them for consistency afterwards. In any other case, the thing I found on the left was not a type parameter. That means that a known part a known part is shit. Because if I have something on the left, for instance, on the left, I know the field of my struct is an int, and on the right, I have something that is not an int. That is not necessarily an error if and only if the type of the thing on the right is itself a type parameter of the surrounding context, like a function, for instance. Because that's something I can't resolve at that point in time. That's tricky. That's tricky. Okay. So let's handle two cases. Which I could handle separately, but I think this makes more sense like this. In this case, it doesn't matter what's on the right-hand side. That's perfect. I will always accept it. No matter what's on the left-hand side, if it's not a type parameter, if it is a type parameter on the right-hand side, then that's fine. We have to allow it. There's nothing I can say. So we do nothing. In any other case, it doesn't matter what the specific diff was, the types don't match. Report an error. Now we have the mapping. For each field we have encountered. Now we need to check a few things. For each type that appears in the struct parameters, that still appears at this point in the struct parameters, we have to check both that it appears in the mapping, and two, that its type is always consistent, as in that there is only one possible value. So that's the temp mapping, and this is going to be the actual mapping. The possible types are going to be a lookup of that parameter name in our temp mapping. And on nothing of that, we'll just report error. That's a new error. Okay. What did I say? I said the path info resolved, which is a type name, which is actually the first argument. So this would not compile in the first place. There we go. And the identifier that is wrong, well, that is not. Basically, what this means is I have a type that is parameterized by a value that has not been provided, either because no type arguments were provided or because a placeholder was provided, but none of the fields of that struct allow me to know what the type is. It's a ghost type, or in a sense. If that's the case, then none of them allow me to know what the type is. I have to signal that this is ambiguous, the type should be provided. Okay. If I didn't report an error, I have the value of the possible types. Yep, can't infer the type if no field has that type. Then when we have that, we have the mapping, which means we have a list. Actually, I'm gonna make it a non-empty list, because if there is a value in the mapping, it's always going to be, I don't have to handle the case of the empty list, which makes no sense. Now, what I'm going to want to check, and that's going to be complicated. No, I don't have to check the product of all of the... Is a non-empty list an applicative? I don't think so, but it is an applicative. Okay. So I can do... But is it completely useless? Like, can I envision a situation where type 1 matches type 2 and matches type 3, but type 2 and type 3 don't match? Yes, actually. If the type 1 is a type parameter that will say yes to all of them, but 2 and 3 are actually real concrete types that are incompatible, I have to do the product. Okay. So, let's do a lift A2 of type matches on the possible types and the possible types, which is going to compute type matches for all combinations. I don't need to do all combinations of left-hand side, right-hand side. I could do something smarter. I'm also going to do it in a separate function, I think, because this adds a lot more complexity here. Let's go back to my type matches and so on. Types all match. That's going to be taking... I'm going to take a list for this. It's going to be easier. And rather than doing it with the applicative and do all combinations, because there's no point in testing the same combination on like left hand side and swapping them. This is a what's the word I'm looking for, when you can change the order of the arguments and it's the same. Not commutative, is it? I don't remember. Anyway, it doesn't matter in this case, which means I can do. So I have list 1, list 2. And I can do for, I think it's tails. Actually, doesn't an empty list have a tail? That'd be fantastic. Tails, actually. Tails. Fantastic. Except it gives me lists anyway. I might as well do it with lists. Okay. So, what I can do... Wait, it's not taking 2 lists, it's only taking 1. What am I doing? So what I want to do is compare one type to all the ones that come after in the list, but not do the permutation. So what I'm gonna do is for each head type remaining types in the tails of types, for each remaining, which each other type in the remaining types, do I want to add, maybe that gives me a unique combination of each. I want to return one element, which is head type matches other type. Okay, and I do an AND on the result, so I return true if that's true for all of them. Perfect. This is called types all match. Unless types all match of the possible types, we are gonna be able to return an error, which is gonna be error, what did I call it? Struct incompatible types with the type name, the parent name, and the possible types. If we have passed all of those checks, then we can return a very simple mapping, which is, hey, this parent name, its type is... Could I try to find the best type and something there? I could try to find... I could try to find if there is more than one possibility. I was going to say the least generic, actually, not the most generic, because if I have a struct that is parameterized by a type t, and I am in a function parameterized by a type u, let's say, and I have two fields in my struct that are of type t, and one of them tells me, hey, t is an int, and the other tells me, hey, t is this type parameter u, I know that t has to be int regardless of whatever u is. So I think if they all agree, I want the most specific because that's the one that's the least likely to change, and that's the one that's going to give me the best error messages down the line, I think. So I think I want most specific type out of all of those possible types. Let's add a new function, most specific type. Yeah, kinda. Most specific type. I could even make it for like any, I might actually do that. This is for any foldable T. Because that way I can give a non-empty or a list and it's all fine. Actually, no, I want this to be specifically a non-empty because I want this function to always return something, and it cannot always return something if it's a list because the empty list is a possibility. Okay, so most specific type for a list of types is going to be I could sort by the number of type parameters that appear. Does non-empty have a sort? It does. It's sort with, not sort by. Interesting. Not sort on, I mean. I guess with makes more sense. It's more conventional to have something named with than on for this, I think, kinda. Anyway, this is gonna be, the result is gonna be the first element of doing a sort with number of parameters. And I don't need to give the type argument. I can make this point free. And I don't think I'm going to need the number of parameters anywhere else. So I'm going to make it a local function. Number of parameters is going to be a function that given some path info will do a case of the path name. If it's a type parameter, it will say 1. Forgot the of. And otherwise, if it's literally anything else, it will do the sum of map number of parameters on the path parameters. Okay? Should be fine. That gives us the most specific type. All possible types. And now we have, for every single type that appeared in the type arguments of, in the type parameters of the structure that was not fully resolved because we did not give all the type names, we do have one most specific type in the mapping. Which means we can do now, I think we can reuse our instantiate function. Oh, wait. Okay, so this needs to be at this level because here this mapping is the one that I have found for one specific field, because I could find more than one diff for one type. So that's the mapping I find for one field. And I don't need to do the from list with at this point. It's enough to return a list. So now I return the list of the diffs for each of the struct values, which gives me a list of lists. Well, it actually gives me a non-empty list of list. Is there some kind of concat in this? There isn't. Okay. But it is a monoid, so an M concat probably exists. It's a semi-group. So S concat exists, but it's only for non-empty of non-empty. Fun. But I guess, therefore, this temp mapping I've been using is a hash map from list with concatenation of the of semi-group union of concatenate of two lists of all the diffs. Okay. So I transform this non-empty list of lists into a list of lists. I concatenate it. I create a hash map using union on when the keys are duplicated. I get a temp mapping. I do this analysis that I was doing there that hasn't changed. And now let's look at instantiate struct. I could use it and simply I could use it if do I want to use it? Will it mess with my cache is the question I have. Because I will have a struct info that is I think I can't use the cache here Yeah, I think I can't use this function. Because anyway, I don't need all of the placeholder logic. The only thing I need is this, which I'm just gonna copy. So here I have my mapping, which means I can do a new values on, I guess new fields, which on the struct values here, I can, well, new values would make more sense, I suppose. I can do a substitute types mapping because now I know what types they're supposed to be. And the result is always going to be a struct info. And I can copy that from the other thing up there. It's always going to be a struct info in which the struct name remains unchanged. The parameters will always be empty because at this point we have figured out the entirety of the we have figured out the entirety of the parameters. I think it's fine to do that. Let me think. Because that struct info is not persisted. No, it's not persisted. So what I want is instead ooh, this is tricky. What I want to do, let me explain what I'm thinking. This function needs to return what the type of the expression is if such type had not been figured out. The type, however, does not involve the struct info. The struct info is lost after this because the only thing that matters for the type is it's that struct there with those parameters, which means replacing the parameters and the fields in the struct info doesn't matter. It's not what I need to do. What I need to do is I need to go through the path info there, and I need to replace any placeholder by its corresponding mapping. But I don't know the name of the placeholder, so I need to iterate on both the list of parameters and the list of the remaining parameters in my struct info. Whew, okay, yeah. That's what we need to do. Path info resolved. Wait. It's even more complicated. Because what if one of my type arguments is not placeholder, but foo of placeholder. This is very close to working, but I think it's incorrect. Let me think again about instantiate struct here. Yeah, the only case I find is, okay, you need a type and you gave me a placeholder. I don't support, hey, you need a type and you give me a partial type that contains a placeholder. I don't do that. Oh, I have to think about this. One idea is to give up on this idea of the instantiating struct. Or rather, keep it the same, but okay, so how do I handle, okay, this thing is parametered by foo of placeholder, because that doesn't work with this. And I think, and I think, I think it's even more complicated because it means I have to create synthetic type parameters to reflect the fact that there are placeholders within. Because I want to be able to confirm that if a type parameter t has been inferred by this to be a foo of placeholder, then I need to check that all placeholders for foo are the same. If here in this thing I don't handle placeholder in any specific way, what I would need to return is a mapping from original name, like t is supposed to be, like this type t was provided with this, and therefore we have a name for it. And either that mapping is placeholder or it is foo of placeholder, whatever it is. And I do the replacing of all the values accordingly. which means I need to return something alongside. I need to not change the type parameters. They need to all be there. I just need to return this mapping of, I need to return this mapping of the type parameters, okay? And then I can check when the struct expression is resolved. How do I will need to identify uniquely the placeholders. No, I will not. Okay, I think that's it. Okay. So, instantiate struct does not give me just a new struct info resolved, it gives me a hash map from identifier to path info resolved, which is the mapping, the partial mapping of the types that appear in the type parameters after this instantiation. I am going to drop the cache. I think the cache is no longer really useful with this. Okay. I don't need to do the partition eithers anymore. Because the mapping is very straightforwardly a from list. And it's not even a thing in the monad because it is that straightforward. From list of zip of those two, and that's it. I replace all of the types within the structure with this. So if you tell me that the first argument is foo of placeholder, then every time the name t appears, I replace it with foo of placeholder. I don't change the parameters. I need to have the original list. Therefore, my result will be on one hand it will be the base in which the struct values have been replaced by the new values, and it's going to be the mapping itself that we keep around for later. Okay. Resolve struct, where are you? There you are. You are now returning a struct info resolved and a hash map identifier path info resolved. Okay. So here in all cases, do I want to replace all of them with placeholder? Does that make sense? I think it does. Wait, I'm gonna need to know. I'm gonna need to not replace. God damn it. This is tricky. This is extremely tricky. I am gonna need to not. I think I'm gonna want to try to do it all of this evening, no matter how long it takes, because this is so much context to carry in my head. As I modify this several times, I want to. Where is that instantiate function again? At the bottom of this, I think. There we go. I think I cannot replace them at this point, because if I do, I lose all sight of the placeholders, of like where they are and how they map to the types. So I think this function goes away after all this time. And here, oops, so I need to add this thing here as well to the type of this callback. Then I will absolutely work through some examples, but I want to finish this. I want to make sure I have an idea in my mind, and I want to make it. I want to finish writing it, and when I get to the point where I'm done writing it without finding other things that don't work, then we'll work through examples. But I think I have something that will not require a lot of changes and is close to working. I will try to finish this. So I will always return the resolved info. I am not going to change the struct info with this. I am going to just return a mapping as well. And that mapping is very straightforwardly then it is simply for each name in the parameters, it is a placeholder type for each param name in path params. Not path params. Struct params. As in the name of that identifier in the type parameters maps to placeholder because it was not provided. If it was provided, we've already checked it is the right name. So this is from list. And otherwise, the list that we are creating is a simple zip of struct params, path params. Okay. And we return that. So this gives us the parameter mapping additionally. And this is going to take all three arguments. And this is going to give me as a result concrete type. Well, concrete, I don't know if that's correct. The fully resolved type, I guess, as opposed to just a resolved type. Okay, so now, once again, and hopefully for the last time, we are going to here, and we're adding the new mapping that we have, which is this hash map of identifier to path info resolved. None of this here changes. Param mapping or something like this for now. So this doesn't change. The diff type, I think, remains the same. The difference is, since we have not resolved any of the types in the thing, it will still say type T on the left-hand side, which is our thing, even if we already know what T is, because we have already provided something in the mapping. Because, for instance, we said that struct foo of int, therefore we know T is int, therefore we should know at this point that the thing is int, but we have not replaced that in the definition, so this left-hand side will still say T, which is fine. This thing doesn't change. For each difference between the type on the left and the right, if the difference is, well, on the left we have a type parameter, we add a mapping from type parameter to value, which is still correct. And placeholders don't appear there. If we have whatever on the right-hand side, on the left-hand side, and we have a type parameter on the right-hand side, yeah, that works. We don't need to do any mapping. That type checking always works because we don't have the full type information at this point. Now we have our temp mapping, which is for every single type parameter that appears on the left-hand side, so only in the struct types, therefore not anything in the surrounding context. Here's a list of types we have found for this. Now, if none of them, if there's no type found, that means it's ambiguous. Perfect. If they don't all match, then that's a problem. And now there's one more thing we have to do, which is we have to match the pattern we have in our mapping with the type that we have on our right-hand side. Because we have identified that, hey, all of the things with type T that appeared on this side happen to be foo of int. Perfect. What was the template we had on the left-hand side? Was it placeholder? Perfect. It's foo of int. Fine. Or was it foo of placeholder? Foo of int is fine. Or was it bar of placeholder? In which case foo of int is not. And that is the last thing we have to do. We have to check that the type that we have in the mapping from the given arguments matches the shape of the type we have inferred. Can I make use of type matches for this? I think so, because placeholder will only ever appear in those kind of things. And therefore, I think it's fine to say that placeholder is equal to whatever else. I could go even one step further and only accept it on the left-hand side, because it's never supposed to happen to appear on the right-hand side, but that feels a bit tricky, and I don't do that for type parameter. So I think I am going to do that. For placeholder, I return true. And I think since I now have equality on types, when I'm done with this, when I have name1, name2, instead of having to write all of the possible cases, I can do name1 equals name2 and okay. So to finish this, long last, at long last, I can do for this parameter name, I can do unless, well, I need to get the mapping. So the pattern is going to be a lookup of that parameter name in the mapping, and on nothing, just an error, because that's never supposed to happen, because we have created one such mapping for each parameter in the first place. So if we don't find it, it's because our code is broken, not because the user did something wrong. So we have the pattern, and unless say candidate is the most specific type of the possible types, unless the type pattern type matches the candidate, oops, I did not copy what I wanted to copy. I wanted to copy this. I was expecting this pattern, and I found this. And at long last, if that is correct, then I have a mapping from parameter name to candidate. I don't even need the list of parameter names, because this is going to be in the order. I purely need the candidates. This is my list of resolve type parameters. And at long last, I can return a path info with the path name, or I guess I could just, it's the type name in which the path params have been set to the resolved type params. And that's it, I think. Whew, that was a lot of work. Now we have a fun task, which is I've been streaming for 4 hours. The last 3 hours I haven't compiled. So let's compile. That's gonna be quite a lot of work. Okay, so why can't you... Ah, yes, I suppose instance is here enough. Could not deduce. Ah, yeah, I suppose. So I'm gonna need to add all of the other constraints. Would equality be required? We'll see in a second. Nope. Okay, that's enough. The parser is compiling, that always takes ages. And then we'll move on to compiling, okay. Built-ins, because I have a typo on hash set. That's fine. That's the only error it could find here so far. Identifier is for now defined in the tokens module, which is not great. I probably will want to move it to its own type at some point. Maybe because the list of reserved identifiers would make sense there. I don't know. Parse error, and there we go. This is for each param name in the struct params. There we go. Expression syntax in pattern. What? What does that mean? Oh, I forgot. One small underscore there. Oh, did I make a mistake when I did change the resolve name in resolve type? Maybe here, because the argument to resolve name is the callback. Oh, it doesn't take. Oh yeah, resolve name doesn't require the mode at all. Okay. So resolve name doesn't need the allow placeholder. That's all fine. Resolve path, however, does require it. So I just need to forward the one that was given to me. There we go. Okay, so that's just my placeholder resolving thing that I have to fix. Oh yes, actual is of course not is the length of the params. This is not what I want. What I want is null path params, which is the same thing as testing that length equals that actually equals 0, I guess, but okay. Here That's because struct params is not in scope. I have not deconstructed the I have not deconstructed the resolved info, so I need to do that here. I need to be explicit that this is the accessor for this struct there, a record I should say, and same here, to the point that maybe I should introduce that's gonna be expected params. Expected params. Expected count, given count. That way it's a bit more explicit. When expected count different from given count and given count greater than 0. Barely fits on the screen there with the slightly smaller font size. But now I can here use expected params rather than having to give the thing everywhere. Same thing here. Expected params. Okay. What are you gonna complain about next? I no longer have report fatal. I have changed it to report error to distinguish from report warnings. Tails is not in scope because list is imported qualified, so it's list tails. Oh, when is reserved identifier. There we go. I have a few more reward fatal that have been left in the code. Oh, I had one left. Identifier is not in scope. Tempted to introduce an alias for this thing so that I can more easily say when that thing is reserved, send an error for reserved identifier for this thing without repeating myself as much. That I have written too much Rust in the last few days. This is inequality in Haskell. Actually, do I want to do that? No, for this is a constant. Constant, there will be no type there will be no type parameters, there won't be placeholders. Therefore, I can use just straight up equality. Okay. And I could do an unless equals, but that's fine. Okay. This is no longer on X and Y. It is on left-hand side and right-hand side because I have changed the way this thing works. Likewise here, left-hand side, right-hand side. And I probably have the same problem in the int, in the addition thing, which is there, except since I've rewritten it, maybe not. Okay, that looks good. Next, non-scope. Yeah, I suppose that for X and Y in the case of addition, this is just plus. Non-scope values. This takes 4 arguments. There's only 3 given here. Values is missing. So this is the case where I am looking at the type of the field on the left-hand side and the type of the expression on the right-hand side. And I'm saying, oh, they don't match because regardless of type parameters, I'm able to say those two don't match. They're just the wrong shape. Something is wrong. That means here, this left-hand side is the field type. I have renamed that variable earlier. And the expression type is not of x because I have renamed it to being the expression. Oops. Struct params. This is because it's struct params. There we go. Let's compare again. I have the same mistake here. This is when is reserved with parentheses because this is one expression there. Couldn't match. Interesting. Yes, it's missing an argument here, which is e2. Yes, I'm interested here. I have already tested the expression type. Now I'm only interested in the expression value. Type diff is not something in the monad, so I don't need to do this with an arrow. This is just a let. To the point where, since I'm not using the diff for anything else, I could just as well do a for on the type diff like this. And take the argument. And actually, I think this always returns the thing. This do argument is not technically required. I can leave it just in case I add more. Okay. And yeah, of course, I hear him saying pure. Do I have to do a concat of a concat of a concat? I think I might have to. Because for each such element in the list, yeah, I only want to return the diff in some cases. Sometimes I don't have to return a diff because it's just I have nothing to say here. So this is only. So I think I'm just gonna have to do pure nothing, pure just, and I have to do a cat maybes on that result. Okay, everything else should be fine. We're debugging analyze, well, debugging. We're making the last function compile. When this is done, we can do some tests. Actual type. What do you mean it's only one of them? Okay, so the type here is wrong. This is supposed to be a hash map from identifier to non-empty path info resolved. From a given parameter name, here's the non-empty list of the types we have found for it. Aha, It's not that the thing has the wrong type, it's that I'm using possible types in the wrong way afterwards, and therefore it gets confused. So types all match. Aha, it takes a list. It takes a list, so I'm going to have to convert that to a list for this purpose. And this error struct incompatible types. Error struct incompatible types takes a non-empty. Okay. So here it's correct. And here I have this most specific type out of possible types. Let's check the type of most specific type. It does take a non-empty path info. Perfect. So hopefully now this should be fine. Oh, this because I have here something that's ambiguous. This on nothing with the dollar afterwards, it was getting confused. Do I have another on nothing? No, it's good. Okay, that's why. And now, resolve type params. Here, I forgot to remove the underscore from the 4. Okay, name shadowing. We like those control lens ISO. I'm going to remove mapping from lens because mapping is a useful name for what I'm doing here. And I'm saying we like those because that's the kind of errors we get when most of the type errors are out of the way. Here it complains about not knowing what this is because I'm saying 1 here and I'm doing sum here. So whatever that number is, it is that type of number. But then I do a sort on it and then I discard it, which means that there's no type indication anywhere for what the type is, and it has to monomorphize to integer, and I have W error on, so it complains about that. So this is a simple int. Unused matches. Yep, I'm indeed not using those matches. Okay, this compiles. I still don't have a lot of tests for the analysis phase because we've been working on it for quite a while. But now we can do some manual tests. So let's remove. First, I'm gonna keep this. And I'm gonna check that now this is broken because it worked earlier this evening and it shouldn't work. Error wrong type in the in build type int and color. Okay, so yeah, indeed here this no longer works. Perfect. However, if I do here as int, that works. Perfect. Now, I should be able to do a constant S0 of type S0 by doing S0 with x being 0. That should still work. I should be able to do a constant S1 0 of type S1, and here the type must be fully given. So this must be, for instance, an S1 of int. And I should be able to do it by doing S1 x 0. That should work because S1 not given type parameters should be able to infer that this is an S1 of int, and therefore afterwards the comparison should work. Let's try to see if this works. Parse error. Because I forgot semicolons at the end of my constant declarations. I forgot something else. What are you complaining about? Line 44. Oh, that's in main. No, okay. Line 8. Oh, yes. I have changed the syntax for struct expressions in this language compared to Rust. It has this operator because otherwise, when purely defining the grammar with happy, the rules were ambiguous, and I could not make it non-ambiguous without having some more look ahead. So I've made this small change. Okay, and now this is because this requires this syntax like Rust. Okay, and now this works. And the type of S10 is, it's a top level declaration S1 with a parameter which is an int and an expression of type S1 with an int. So that works. We didn't give the type parameter and it worked. Now I want to do something else. I want to test if I give this a parameter which is a character. This should work. It should be inferred as an S1 of character, and then it should fail here because I have said that this is an S1 of int, and this is incompatible. Error wrong type, because I have on the left-hand side an S1 of int, and on the right-hand side I have an S1 of character. The type inference worked. Okay. Yes, I am absolutely going to try some S1 of S1 next, but there's more things I want to try. I want to try, what if I have two fields of type T, and I'm not giving the type T here, but I have X, C, and Y as 0. This should be rejected because I did not give a name for T, and it cannot infer that they're both the same type. Incompatible types for T, because I have both int and character. Yeah, the other way around should be perfectly fine. Yep. Incompatible type, we have character or we have int. So that works. Now, what happens if I specify int? And now I get, aha. That's interesting. That maybe suggests I should figure out a better... I guess I can report this with the error messages, because with the error messages, I know at this point if the type T was provided or not. So I can figure out, like, oh, it says incompatible type for T between character and int because it's still trying to do this resolving despite the fact that t is known at this point. I guess I could make this better in the first place. I can make this better. I can make this better because here I only report the error if it's known. But here I could do a type matches. Yeah, here I could do a type matches that will give me a better error. I can add that. And here I will just need to find the candidate, which is, well, the type pattern. And the mapping, the pattern is this. Because if it doesn't match the pattern, I don't need to go any further. I know that the pattern is whatever the thing was given. I can just discard it at this point. Which means, actually, that when I reach this point, I've already guaranteed that every single mapping matches. Wait, no. Oh, I have to be careful. Here I'm in the case of the diff, which is not the same thing. But this, however, I can do. And there's no such thing as, all right, this is the expression type of the expression. Wait, no, that's wrong. And I can't do that. I cannot do that because the name of the field is not guaranteed to be. Huh. Let me think for a sec. No, it's here that I can do this. There we go. Because here I have made the diff. I have found something that matches a type parameter on the left and something else on the right. I can check that it matches this thing on the right. And if it doesn't, it's not even worth considering it as a candidate. It doesn't match the pattern I have established. Therefore, I can just do that with the right-hand side and otherwise return this mapping, which means here at this point, I no longer need to do that. Okay. File, find errors. I can just return directly pure most specific possible type. Yes, I don't need a type pattern anymore because the type pattern has been checked at every single call site already. Okay. So now, if I say this has to be an int and I provide a character for a value of the type, I should get wrong type, expecting int found character. And if I remove the type parameter here, I should be back to incompatible types for t. I have a character on one hand and an int on the other. Okay, sorry, I had missed your messages. I think double field is already handled. It was already handled before I started this evening. If I do that, I will have, regardless of what's in there, it could even be true for what matters. The first thing we do is duplicated field for S1, X appears more than once, basically. So that's already handled. Now, what I want to do, I can't, since I don't have functions yet, I can't test more difficult things. I can't test the most, unless I like do write specific tests. I can't do tests at this level for the most specific type stuff. But I can test something that I've been wanting to do. So first I can test placeholder. If I remove the duplicated field, aha, I get a struct. Yeah, of course, because I have still this. Now it works. I declare this as a placeholder, which is the same thing as not declaring it, and it works. Now, let's go for something a bit more complicated. I am going to say that the argument to S1 is a S1 of placeholder, which means I am not inferring the value of t, I am inferring the value of the placeholder within t. And let's try first with an S1 of, I'm not going to say it, of int with x0, y0. And an S and y, which is an S1 of character, with x being the character 0 and y being the character 0. What I'm hoping here, what I'm hoping for is this will infer x and y properly, despite the type arguments not being given. We know this is going to work. And then it's going to check that they're both compatible with the shape of the pattern. However, since both of those are of type t, it will create a mapping from t to S1 of int and a mapping of t to S1 of character, and it will therefore fail. Syntax error somewhere. Yes, because this is S1 with an at. There we go. What did I mess up here? Oh, actually, this is supposed to be in this one of S1 of int here. I need to fix that. Why? What is it unhappy about? On line 1232, I've changed something. So 1220. Oh, because S1 requires, there we go. Okay. Oh yeah, multiple declarations. This is S1 1. Struct incompatible types. That's good news. Because it was expecting an S1 Because yes, this is an S1 with type parameter placeholder, which is correct. The type parameter t could be either an S1 of character or an S1 of int, and it cannot be both. Those types are incompatible. And now, if I make them both int, despite the fact that the placeholder is on a nested type parameter, this compiles, this works. And its type is indeed an S1 of int. Okay. Now, what do we test next? I'm very happy this works. This was a lot of work, and I'm very happy it works. I can't copy. I don't have Twitch open on this computer, so I can't copy what you said. Oh, having nested of multiple parameters. Yeah, sure. Let's do that. You're suggesting keeping the x and the y. That works for me. Actually, I'm going to keep x, y in all of them for a consistency so that all of my things are... And there we go. And y is u in this case. Yeah, that's more readable. I'm going to keep those constants as they are because they work, and that's good enough for me. So you're suggesting constant... I'm going to call it S2. Oh, I don't know. It's S12, I suppose. Which is of type S1 of S2 of S1 of int S1 of int. Okay. And that should be an S1 that we build. No need to give the type arguments. And I'm going to build it kind of like how a Haskell thing is constructed, like this. It has two values, which are both of the type S2 something. So it's going to be x is an S2 of something, followed by y. Actually, I could almost do... Oh, if I do this, it's going to format it as if it were Rust code. It's going to be very confused. Yeah, it's confused by the... It's confused by the at symbol. So I can't use Rust mode for this. Until I rewrite the parser completely to get rid of happy and write a proper recursive distance parser, and I can actually support the same grammar as Rust without having to introduce new symbols because happy is not good enough for this. Okay, so this is now this. They're both S2s, but within them, this X is an S1. To make it more interesting, I think I'm going to give it two different parameters. I think the S2 is going to be a character here. A Boolean, for a change. I still have flight check enabled by mistake. Okay, let me just reopen this file. There we go. So this is the S1 within the S2 within the S1. Actually, I'm going to make it even more explicit like this. And that S1 has... It is the first argument of the S2, so it's an S1 of int. So that's an x0. and a y0. Then in that S2, we have y, which is an S1 of character, which is this nonsense. Oh, Boolean. True. And y false, because why not? That's also going to be a good way to discover whether those constants actually work, I suppose. And that's the end of this S2 within the S1. And now we have to do the same thing. And I'm going to copy it here for the second S2 within the root S1. And let's not forget the semicolon at the end. A restrict missing field. Interesting. Oh, yes, because here I have an x0 and I've added an ay to my s0 now. Okay, this compiles, and this nonsense is indeed this S11. I'm looking for S12. Where are you? S12. There we go. It's this gigantic thing. I'm gonna actually... Where does it stop? Here. If I open the scratch buffer, can I change it so that... I'm gonna make it so that every opening bracket goes to a new line. God. Because the problem with this is the struct expressions carry... a struct expression carry the type of a struct, which is the resolved type, as in name and arguments, and an expression also carries the type of the expression, which happens to be the same. So every single struct expression in this here contains the full type of the sub-expression, followed by the type expression, which contains the same thing again. So this is why this thing is so monstrous for just one constant. But yeah, we've made it work. So to sum up, what are we doing this evening? Because we've made so much work for anything but the thing we started with. Because I started saying 5 hours ago, I started saying, tonight we do analysis of functions. The very first thing I did was like, well, actually, let's do this thing about type parameters and write a with type parameters so that they're always scoped properly. I don't have to do this in every top-level declaration. Doing so, I realized that there were a few issues with this, that there was a warning I was missing, there was a bunch of things. Then we discovered the struct, I think thanks to you, because you made a suggestion with like the struct and the type arguments, and I realized that like, oh, I don't do type parameter substitution correctly in struct expressions, therefore I get type errors despite the fact that it is correctly typed. And here we are with a pretty significant diff. What's the diff stat? Let's see. Yeah, it's not as much as I thought, but it's still Haskell and it's one evening. It's not too bad. Yeah, analysis has been changed a bit. Huh. I have some weird alignment of my buffers there. Okay. That is a lot of progress. We fixed a lot of bugs this evening. And now we have support for placeholders and things. Oh, one thing I haven't tried. I want to try partial specialization of things. For instance, if I have a constant s2 0, which happens to be an s2 of int and int, or boolean, because I want it to be all the same, and I create that with an s2 of that I don't give arguments to. That's not work. We know it works. It's fine. 0, y, true. This is fine. It works. I'm just going to comment out the others so that the output of this is readable, because this is monstrous. Except, of course, I forgot the closing semicolon. Okay. So now S2 0, perfect, it works. Now what I want to try is I want to try giving partial type arguments. This is int and underscore. This is underscore and boolean. It should work just fine. It doesn't, because I forgot this. I will forget them all the time. And it works just fine. We can test more fun things. We can test more fun things because I can do a thing where, yeah, I'm happy with this evening. I've had less productive evenings on this project. I want to try something. I want to try some constant z, whatever, which is an int. So boolean, even. Let's go with a boolean. What I want to do is I want to try expressions of structs without type arguments in which the struct is not persisted because it is removed at compile time. By which I mean, can I do this? Can I do... I'm going to introduce just another one with one type argument for this thing. I'm going to call it S3. I don't know. Just for simplicity here. Can I do an S3 of x equal S3 of x is S3 at x is the character star, close, 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 dot x, dot x, dot x equals star. Or even S2 of x is 0, y is star of y. Semicolon. Z is true. This works. This works despite the fact that we no longer have the actual full construct type here on the left. This is a purely anonymous structure with none of the types given, and it type checks. And if I do x here, I will get wrong type, expecting a character, got an int. Whew. Well, I'm happy with this result. That was a lot of work to get there. There is, I think, something else I want to try. There is something else I want to try. It can be an int, it doesn't matter. What I want to try is I want to try to have I can't do that yet because I don't yet have surrounding type parameters. Since constants don't allow type parameters and I don't have functions yet, I can't test having two fields for something, one being more specific than the other, but both being compatible with the schema. I can't do that yet. So I won't. And I think I'm gonna leave it here for this evening because whew, that was a lot of work. Oh, do I support casts for? No, I don't support casts for struct. I think because that makes no sense. I think. Although I guess I could check. I could check on the cast like, oh, all of those arguments are the same. Therefore, I don't think I want to do that. Okay, but yeah, the fact that this works, that we're saying like the S3 of S3 of S3 with that saying a single type, and then we do the field call, and it does work with this anonymous S2 thing with another type given in the world. That is nice. I'm happy about this. Okay, and yeah, I think I'm gonna stop here because I have made zero progress on resolving functions, but I have made a ton of progress on everything else. And yeah, I guess next time we can make progress on resolving functions. Now that we know that type parameters and placeholders and all that nonsense works, we can start going through a function statement and start going through a function and type checking it. And there will be at some point, I have not kept the instantiation of structs because it's something that really depends on each call site. And there isn't that much actually to do on that point. It's just like resolving the type parameters. I will have to do function instantiation, and that's going to be a nightmare. It's not going to be a nightmare. It's just going to be a lot of duplicated work because it's going to be basically, hey, we have this already resolved function, but we need to go through the entirety of the function to check every single place that had the type T thing. And basically, every time that's the case, we have to recheck for equality all of the types everywhere. That's not gonna be fun. Which means I might want to change something. Come to think of it, I will probably want to. I will probably want to extend my trees that grow thing because I will probably want to keep the declaration of the things I have used. For instance, at the call side of the function, I will probably want to know, okay, it was actually this function in this module that was called there, and here also is its declaration, so I can look at its arguments when I do the instantiation. I might need to do that. I'll think about it for next time. I think for now, I'm going to stop because it is late and I am tired. And it's too late for me to start Deltarune, so it's going to be tomorrow, I guess. How many of my friends are playing it right now? Only two. I'm surprised. Anyway, thank you for tuning in. Thank you for your comments. Thank you for your questions. And yeah, I'll see you all on Tuesday.